Good morning, dear students. Today, let us study Chapter 7 Motion, Force, and Work. Observe and discuss. Here you can see a man riding a horse, a cow grazing, another man pulling a cart, and a gas stove on which a cooker and a vessel is kept. Now, let's recall what is meant by motion. Objects, when they change their original place or position, means motion. Now, what causes a change in motion? So, we all know that when force acts on a body, it causes a change in motion which can stop an object or slow down an object or change its direction. Now, we have seen that change occurs in motion or the shape of a body when a force acts on it. Now let us see how work is done when a force acts. Now let's learn the concept of distance and displacement. Ranjit's house is at a place A. You can look at the figure 7.2. The figure alongside shows the distance traversed by Ranjit to reach his school at D. If we do not take direction into account, we find that Ranjit traversed means travelled, a distance equal to AB plus BC plus CD. However, on doing this, his displacement was equal to AD. Ranjit's displacement from his house to the school is shown in the picture with the broken line AD. AD is the minimum distance along a straight line from Ranjit's house to the school. The minimum distance traversed in a particular direction along a straight line is called displacement. So you can mark this definition of displacement. Now let us learn what do you mean by speed and velocity. So what is meant by speed? We'll be studying about it, but still I would like to tell you what is speed. Speed is the rate at which an object covers certain distance. I shall repeat it. Speed is the rate at which an object covers distance. Now, what is the formula for calculating speed? So the formula is distance travelled upon total time. We'll be learning about it. So distance travelled upon total time. When we say that the speed of a car is 40 kilometers per hour, there is no need to specify the direction. But to predict whether a storm will reach a particular place or not, a mention of its direction is essential. You are listening to the news every day. In that, they tell us about the speed and the direction of the wind, the rain, the storm, etc. So it is necessary here to know the direction. Now, let's look at this yellow box here. The definition of distance. Distance is the length of the route actually traversed by a moving body, irrespective of the direction, is called distance. Distance is a scalar quantity. So you have to learn and write this definition. Next, displacement. Displacement is the minimum distance traversed by a moving body in one direction from the original point to reach the final point is called displacement. In displacement, both distance and direction are taken into account. Therefore, displacement is a vector quantity. The unit of measurement of distance and displacement is the meter in the SI as well as in the MK system of measurement. So the definition of displacement you have to learn and write. Next, what do you mean by velocity? Velocity is the distance traversed by a body in a specific direction in unit time. The velocity of a body can be calculated by the following formula. Velocity is equal to displacement upon period of time required for the displacement. So students, this definition also you have to learn and write, and also this formula. Now let us play a video.
We have seen previously that speed is the amount of distance covered in a given amount of time. It's nothing but distance covered over the time taken to cover that distance. Simply put, it tells us how fast an object moves. Also, if we know the speed and the time taken to cover a distance, we can easily find the distance covered. So if I tell you that I traveled at a speed of 50 meters per second for 1 minute, can you tell me how much distance I covered? I am sure you've come up with the answer. I have covered a total distance of 3,000 meters. But if I covered 3,000 meters from this point, am I here or over there? You had no clue as to which direction I headed off. This tells us something interesting. Speed offers only the magnitude, making it what we call in physics a scalar quantity. It doesn't specify the direction. It just tells us how much ground is covered in unit time, regardless of the direction traveled. Scalar quantities have only magnitude and do not specify direction. Do you remember the difference between distance and displacement? Distance just tells us the distance covered, but displacement is distance with direction. Say the distance between towns A and B is 20 kilometers. So if we take a 50-kilometer route from point A to B like this, then the distance covered is 50 kilometers and the displacement is 20 kilometers north of point A. So speed does not tell us the direction. Is there anything that tells us the speed along with direction? Yes, it's velocity, which can be written as lowercase v. Let's see how it differs from speed. What if I tell you that I traveled north at a speed of 50 meters per second for 1 minute? Would you be able to tell me where I landed up? Yes, you would know I have covered a total distance of 3,000 meters and landed up at this point. Velocity is speed with direction of motion. As such, velocity is direction aware. So when you mention velocity, you must keep track of direction. Something like the car moved south at 55 miles per hour. If you do not mention the direction and just say the car moved at 55 miles per hour, you're not stating the velocity anymore. What you are stating is the speed. What do you think is the unit of measurement for velocity? The unit of measurement for velocity, just like speed, is meters per second. Now you might ask, why meters per second? The cars we drive indicate speed in miles per hour or kilometers per hour. So why is the unit for velocity meters per second? The established SI unit of measurement for velocity is meters per second. And SI stands for International System of Units. This helps everyone in the world adhere to one common style of measurement. Imagine the confusion created with different measures like miles and kilometers, gallons and liters, US gallons and imperial gallons, etc. Incidentally, speed and velocity are both measured in meters per second. But do you remember which one is a scalar quantity and which one is a vector quantity? Yes, speed is a scalar quantity and the velocity is a vector quantity as the direction is also specified. Now let me ask you an interesting question. What is average velocity? To make it a bit easier for you, let's look at the example we looked at in our first video on motion. You have to travel 20 kilometers up north. But because of the roadworks, you took an alternative path which totaled 50 kilometers and you took 2 hours to reach the destination. This was your path of travel. Let's make 2 columns here. One for average speed and another for average velocity. Do you remember how we calculated average speed? Yes, it is the total distance covered over the total time taken. So 50 over 2 will give us 25 kilometers per hour as the average speed. Now what will be the average velocity here? The average velocity depends only on the start and end points regardless of path taken. Do you remember we had learned about displacement? So the average velocity equals displacement over time. What is the displacement here? It's 20 kilometers up north. Distance with direction. So the average velocity will equal 20 kilometers over 2 hours, which will equal 10 kilometers per hour. That's the concept of average velocity.
Now, let us find the unit, task, speed and velocity. Write the formula. Speed is equal to distance upon time. You can take your pencil and just write it. Speed is equal to distance upon time. Velocity is equal to displacement upon time. Then write the units of the quantities. Distance is in meters and time period in seconds. Displacement again is in meters and time in seconds. So I hope you have written these units and whatever is needed here in the space. So insert the units instead of the quantities in the formulae and you will get the unit of speed and velocity. The unit of speed or velocity is written as meters per second square. Let us now use the above formulae to find out Ranjit's velocity and speed when he goes to school as shown in the figure 7.2. The actual distance traversed by Ranjit from home to school is equal to AB plus BC plus CD. That is equal to 500 meters plus 700 meters plus 300 meters is equal to 1500 meters. Total time from home to school is equal to 8 minutes plus 11 minutes plus 6 minutes is equal to 25 minutes. Ranjit's displacement from home to school AD is equal to 1000 meters. Thus, Ranjit's velocity when going from home to school. Velocity is equal to displacement upon time. That is equal to 1000 meters upon 25 minutes. That is equal to 40 upon 60 seconds. That is equal to 0.66 meters per second. Ranjit's speed while going to school. Speed is equal to distance traversed upon time taken. So 1500 meters upon 25 minutes. That comes to 60 meters upon 60 seconds. That is equal to 1 meter per second. Ranjit did not take the straight route of minimum distance while going to the school. Therefore, the magnitudes of his velocity and speed came out to be different. Had Ranjit actually gone by the straight route AD, then the magnitude of his velocity and speed would have been the same. So I hope you have understood this concept. Now let us learn about average velocity and instantaneous velocity. Instantaneous means immediate, instant, at that instant. The velocity of an object can change even while it is moving along a straight line. Suppose that a truck is covering a distance of 40 kilometers from A to D in a straight line, that is, its displacement will be 40 kilometers. If it requires altogether 1 hour for this, its average velocity is 40 kilometers per hour. However, if the truck traverses the 10 kilometers distance AB in 10 minutes, BC in 20 minutes and CD in 30 minutes, then velocity for the distance AB in kilometers per hour is equal to 10 kilometers upon 10 minutes. That is equal to 60 kilometers upon 60 minutes. That is equal to 60 kilometers per hour. Now deduce the velocities for the distance BC and CD and we see that the velocity of the truck is different in different segments of the road AB, BC and CD. However, the average velocity for the entire route AD is 40 kilometers per hour. The velocity at a particular moment of time is called as instantaneous velocity. You can just mark it. The instantaneous velocity can be different at different times. Now, let us go to the next page. Let us learn what is acceleration. Now, in the previous example, the truck covered the distance AB at the velocity of 60 kilometers per hour, BC at 30 kilometers per hour and CD at 40 kilometers per hour. It means that the velocity for the distance CD is greater than the velocity for the distance BC. From the number of seconds required for this change in velocity to take place, the change in velocity per second can be deduced, means calculated. This is called acceleration. So what is the cause of acceleration? Now let us see the formula in the yellow box here. Acceleration is equal to change in velocity upon time taken. You have to learn this formula and also write it. You know that the truck driver increases or decreases the velocity of the truck by means of the accelerator. You might have even seen a toy car that runs on clockwork spring. When it is released on a flat floor, after winding up the spring, it goes in a straight line. However, when it is hit on one side, it changes the direction and keeps going. If it collides into a wall, it stops. It means that its velocity changes. How did this change take place? It happens because the car comes in contact with something external to it. On a football ground, how does the direction of the ball moving in a straight line change? We see some player changing its direction by kicking it. When its direction changes, the velocity of the ball changes. That is to say, its acceleration takes place. The interaction that brings about an acceleration is called force. You can just mark this last line. The interaction that brings about acceleration is called as force. So force acts on a body. Now use your brain power. The unit of acceleration is meters per second square. So verify this. We know that acceleration is change in velocity upon time taken for the change. So that is meters per second upon second. Therefore, it becomes meters per second square. So I hope you have followed this. Now let us watch a video.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour, and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the
So students, I hope you have understood the concept of acceleration. Now let us move further. Force and acceleration. Take a glass marble and let it roll on a big, smooth tabletop. After some time, its velocity will decrease and it will stop. On a carom board too, the carom coin pushed by a striker will move forward some distance and then come to a stop. If the coin is pushed after applying talcum powder to the carom board, it will keep moving for a long time and then come to a stop. What can we infer from this? The velocity of the coin decreases due to force of friction and then the coin stops. If the friction between the carom board and the coin is reduced, the coin keeps moving for a longer time. It would mean that if no force of friction is acting on a moving body, it will keep moving with constant velocity. The scientist Sir Isaac Newton was the first to study force and the resulting acceleration. So, Newton's first law of motion. If no force is acting on a body, its velocity does not change. That is, the body does not accelerate. In other words, if a body is stationary, it will remain stationary. If it's in motion, it will continue moving with the same velocity and in the same direction. You have learned what is meant by force. You have seen that a body is accelerated due to force. Suppose you place the 1 kilogram standard weight on a surface with no friction and pull it with an acceleration of 1 meters per second square. The force applied is called 1 Newton. We have seen this in chapter on measurement. Now, use your brain power. Acceleration is a vector quantity. Is force too a vector quantity? Yes, it is also a vector quantity. Now try this. Place a weight of 1 kilogram on a smooth wooden table. Spread some talcum powder evenly on the table. Now pull the 1 kg weight with an acceleration of 1 meters per second square. Again pull it with an acceleration of 2 meters per second square. It means that now you have pulled a force of 2 newtons. You will have to take many tries for this experiment. Force is measured by the acceleration that it produces. We have learned about the relationship between the displacement of a body resulting from the force applied to it and the work done. We have also learned about the work energy relationship and that the ability to do work is called energy. Okay, we have learned about this. Now, let us see what do you mean by force, displacement and work. In the figure alongside, a string is tied to a wooden block on a table, is passed over a pulley and tied to a weight. On applying a sufficient weight, the block will be seen to move. Which force is being applied here? How can this force be increased? What will happen on applying more force? When can we say that work is done by the applied force? Now, if the block moves forward, we can say that it has been displaced. Due to the displacement, we say that force has done some work. Can we measure this work? We know that work done depends on the force and the displacement. The following formula expresses this relationship. Work work done, that is W, by the force is equal to force F applied to the body into displacement S of the body that takes place in the direction of the force. So W is equal to force into displacement. W, that is work, F is force and S is displacement. So W is equal to force into displacement. You have to learn this formula. In the SI system, the unit of work is joule, while the unit of force is Newton and the unit of displacement is meter. In the CGS system, the unit of work is erg. So you can please mark this last paragraph and learn these units. Now look at the yellow box there. If a force of 1 Newton parallel to the surface of the table is applied to a wooden block on the table and the block is displaced by 1 meter, then it can be said that the force has done 1 joule of work. In this example, The displacement is in the direction of force. So I hope you all have understood this chapter. Okay.